and once we get the equilibrium constant, we can predict the composition of any reaction. So for example, we have K more equal to 1, K less than 1, and K more than 1. So each of this value give or indicate what kind of reaction it is. So let's see. So for the equilibrium constant, the equilibrium constant is measure of extent which a reaction proceed to completion. So by looking at the constant, we can see or we can state how the reactant and product interact in the mixture. For example, if from here, let's say we calculate it and we get a constant is equal to 1, so it means that the product and reactant is at equilibrium. So if the equilibrium constant is more than 1, it means that the equilibrium will lies to the right. So here is product or dominant. So this one is product and this one is reactant. If more than 1, the product will be dominant, product will be more than reactant, while if we have a less than 1, the reactant are dominant at the equilibrium. So this K value give us something. So from there we can extract or we can know information from our reaction. So this is the important thing that we need to know. So checking compression, first question. So let's calculate the equilibrium constant for this reaction where hydrogen gas will react with iodine gas. We have a 2Hi. So given this delta Rg0 equal to 3.40 kJ per mole. So the question asks us to calculate the equilibrium constant at 25 degrees centigrade. So again, we do have our formula K equal to expression factor of Rg0 over Rt. Don't forget this minus. And also we need to remember that R is our gas constant. We can calculate it as 8.3145 joule per mole per Kelvin, or we can rewrite it as 0.008345 kilojoule per mole. So the difference is a kilojoule, or also you can write it as 8.3145 10 times power of -3 kilojoule. So it depends on you which one that you want to write. It depends on you, and please make sure about the dimension of your calculation. So I will not repeat it because we already go through it in our material chemistry. So in any question, we need to make sure that our dimension is uniform. So and then we can have a correct answer then. So for example, okay, so what we need to do is we substitute everything in all the value in our equation. So here we have 3.4 kilojoules, kilojoule per mole. So what we did this one, so what we need to do is you need to use either this one, this or this one. So here I use it 0.008345 kilojoule per mole per Kelvin. So from there, what we can do is we can everything here. So and then you can eliminate all the dimension here. So next what we do have is k equal to 0.25. Please we have this answer. So you can try by yourself. Later on, we'll see a standard reaction gives energy, or delta RG naught. So for delta RG, we will have two equations. So here the equation we do it. So if you remember, we have the delta RG, delta G, delta H minus T, delta S. So again, in this equation, what we need is we just change it. We just put a factor of R here. So it means that this is the direction gives energy. But still, it is energy, and also delta G we can represent it by delta G naught equal to summation of a product and summation of a reactant. And also for this R and F, R means a reaction, F is information. So which depend on we just label it. So if we have a lot of reaction, we know which reaction it is. So here is the standard give energy of formation. The standard reaction gives energy per mole of the species for its formation from the element is their reference state. So here is just a definition of delta G naught. There's a formation of this energy. So you can read myself for this one, and then also in chemistry, if you still remember that in reaction we can state either this one is either the chemical reaction is integral reaction or exogenous reaction. What's meant by integral reaction? What is meant by integral reaction? Integral reaction where it is not spontaneous, and exogenous reaction is spontaneous. So what's meant by this one? So integral reaction is where the delta G naught is more than 0. So if it's more than 0, the K will be less than 1. So we can say that this compound is unstable or undergoes integral reaction. So if K less than 1, we can say that this reaction is tend to decompose into its reactant. So here is product and here is reactant. So it's K less than 1 it have a spontaneous tendency to decompose into its reactant. Here in this case is O2. Our reactant is O2 or oxygen under certain conditions. So still remember, you need to refer back at what I say about the K equal to 1, K less than 1, and K more than 1. So here the value of K is 2.7 times the power of negative 59. So it's absolutely clear, crystal clear. This one is a K less than 1. So that's why we can state that this reaction have a spontaneous tendency to decompose into its reactant, where in this case is oxygen. And for the exogenous reaction, the exogenous reaction is a spontaneous reaction. Why? Because this delta G less than 0. And then we can say that K is more than 1. So this compound is thermodynamically stable or exogenous reaction where it will be releasing the energy. So for example, if we do have this kind of the reaction to cover it with 3 oxygen, we'll have ethane. And then what we'll have is the delta G. Normally the delta G of formation is less than 33, it's less than 0, while the K or our chemical constant is more than 1. So we can state that the formation of ethane gas is spontaneous. Sorry, I think I made a mistake here. So it's not 3O, it's not 3H2. Okay. So again, to check our comprehensions, so determine the standard reaction give energy at 85 degrees centigrade for this reaction. So we'll have the reaction of hydrogen gas react with oxygen, so we will have water or H2O. So given letak RH naught H2O to liquid equal to minus 285.83 kilojoule per mole, and letak entropy of the reaction is minus 163.34 joule per Kelvin per mole. So here what is the differences here is J and K. So again, please make sure the dimension is right before you calculate any kind of calculation. So again, we know to find the reaction, we will have so we have data here, data S, and also here temperature. So we know that we have a few formula of lethargy or gives energy. So this question provides us all of the data. So from there we know which formula that we need to use. So now we have delta J minus delta J equal to delta H minus delta S. And again, delta H, here we have this one, just put it in a formula, just substitute it, minus, and then minus 295 Kelvin. So we need to know that how to change degree centigrade to Kelvin. So the factor is 273 plus S. Okay, so that's why you have 295 times it. So what I did here is I convert it joule to kilojoule. So that's why we have minus 0.1634 kilojoule per Kelvin per mole. So remember this one to convert it to correct value. So our answer will be approximately will be negative 207.13 kilojoule per mole. And for this question, let's do it together. So here is to give energy for the formation of carbon dioxide from carbon monoxide plus O2. So from here, what we need to do is, given this formation of this one, so what we need to do is, we know that they are right. I think here should be from here. The Fg naught, the F equal to delta G naught product minus delta G naught reactant. So here what we need to do is we need to remember this one. So it means 2 mole of carbon monoxide react with 1 mole of oxygen, and will produce 2 mole of carbon monoxide. So that's why what we need to do here is we have 2 mole of carbon dioxide as our product. So the value is 394 minus we have 2 mole of carbon monoxide, because you need to remember this value is for 1 mole. Now we have 2 mole. 2 times minus 137 plus O2. So if we simplify it, we will have 2 times negative 394 times 2 minus O2. So we will have O2 will be negative 514 kilojoule per mole. You need to remember with the sign here. So I hope you can do it by yourself. I already put in how you want to answer this question. So please do it by yourself, and if you are unable to understand it, please leave it in the comment and we can discuss it from there.